On December 15th, 2011, humanity witnessed a bright comet go straight through the corona of the Sun. This was the perihelion of Comet Lovejoy, which was brought within only 140,000 kilometers of the Sun's surface, and traveled at over 500 kilometers per second. Because of this intense encounter, astronomers did not expect Lovejoy to survive, but hours later it emerged on the other side of the Sun. Lovejoy is part of a very special group of comets called the Kreutz Sun-grazers. These comets are thought to have originated from the breakup of a larger comet from several centuries ago into thousands of fragments. And astronomer Heinrich Kreutz was able to show that these fragments are all related to each other. The Kreutz Sun-grazers differ from traditional comets. The comets that are more well-known, like Neowise, Hale-Bopp, or Leonard, all originate from the Oort cloud. The furthest point in their orbit is the Oort cloud, and they are brought all the way to the inner solar system. They aren't usually brought too close to the Sun. Comet Hale-Bopp in 1997 came as close as about 0.91 AU from the surface of the Sun. Neowise in 2020 was brought to within 0.3 AU. The Sun-grazers are brought far closer than that. There are more examples. The Great Comet of 1680 came within only 200,000 kilometers of the surface. And notably, the Great Comet of 1965 came within 500,000 kilometers of the Sun and was broken into 3 fragments. One consequence of such a close approach is the amount of off-gassing emitted. Comets are balls of rock, ice, and frozen gas. When they are far away from the Sun, it remains frozen. However, when they approach the Sun, and especially when they are close, sublimation occurs at a very high rate. This can cause the comet's tail to become all the more brighter. They can exceed 1 million kilometers in length, making for spectacular views from the Earth. The conditions that these comets endure during an encounter with the Sun are nothing short of intense. Comet Lovejoy was exposed to temperatures of over 1 million Kelvin for a whole hour, and this produced a tail with a magnitude as bright as -3. Some more of the brightest sun-grazers ever seen were the great comets of 1106, 1843, and 1882, all of which were easily visible during the daytime. The Kreutz Sun-grazer group has thousands of members, and very few of them become as bright as the great comets mentioned. This means that for a long time, the sun-grazers were extremely difficult to observe, with the glare of the Sun inhibiting any telescopic observations. This was until 1995 when the European Space Agency launched the Solar and Heliospheric Observatory, SOHO. For the past 30 years, SOHO's main mission has been to study the Sun, and it's equipped with a coronagraph to block out the Sun's light to observe the corona. This has led to SOHO discovering over 5,000 comets on its own, most of which could not have been seen due to the Sun's glare. In fact, comets are still being discovered by SOHO to this day, with an average of 1 comet discovered every 3 days. About 85% of all comets that SOHO has ever identified have been Kreutz Sun-grazers, which shows how pervasive these comets really are. Even with SOHO's high rate of discovery though, these comets are still not discovered until their last moments, and many probably go without discovery at all. None of the smaller sun-grazers have survived their perihelions, and of the larger ones, only Comet Lovejoy and the Great Comet of 1843 are known to have survived, although both broke up into fragments after the encounter. A question we can now ask is, when will we observe another great Kreutz Sun-grazer, and what is the future of the group? The population of sun-grazers has remained mostly stable throughout the last 20 years, so there's no indication that their population is decreasing. However, it is thought that over time, their orbits will be dispersed by gravitational perturbations, As for when we'll see another spectacular sungrazer like Comet Lovejoy, we can't know for sure. Over the last few centuries though, there have been several great comets that have encountered the sun, so it's fair to say that we'll see another one at some point in the future. When this will happen is impossible to predict, because most comets, even non-sungrazers, aren't discovered until weeks or days before their perihelion. The Kreutz Sungrazers have been the source of some of history's most spectacular comets, and only time will tell when we'll get to see the next one. Sun-grazing comets may have been observed around other star systems as well. In this case, they'd of course be called star-grazing comets. A strong candidate is the star Beta Pictoris, located 63 light-years away in the southern constellation of Pictor. Beta Pictoris is a very young star, only 23 million years old, which explains the large protoplanetary disk surrounding it. Within this disk, we have the formation of planets, many fragmented asteroids, and possibly cometary activity. Spectral observations of Beta Pictoris show short-term variability, which can be explained by the presence of small comet-like bodies that fall towards the star and evaporate. These bodies would also explain why there is such a high gas content above the main plane of the disk. Studies did suggest that they're probably not traditional ice comets, however, and are probably more like ice cores with their surfaces made of inorganic material. Thanks for watching. If you'd like to see more videos like this, please subscribe to the channel and check out some of my other videos. Clear skies, everyone.